A submarine is submerged and in distress. It shoots a flare into the air to signal for help. The height of the flare in feet f of x and its time during the air in seconds x can be modeled by the function f of x equal to negative 2x squared plus 12x minus 4. On a previous problem, I calculated and I recorded all of the key features. So now I'm going to interpret each scenario and match it to its appropriate key feature, beginning with the x-intercepts. Now, if I turn to the graph, notice that the submarine is deep and submerged, and it's stuck underwater. It shoots a flare, and the first x-intercept is going to represent the flare exiting the water. The flare is going to go up, it's going to peak, and then it's going to die out and fall back inside of the water, underwater. So the x-intercepts, for that matter, represent the time that, for one, the flare exits the water, and secondly, the time that the flare drops back underwater. Now let's turn our attention to how deep the submarine is. The submarine, remember that it's submerged and in distress. So the submarine is going to be represented by the y-intercept. That's going to be 0, negative 4. So in terms of the scenario, we can write it as 4 feet deep. Since deep, in this case, is going to represent a negative quantity. Now, how high does the flare go? Well, the flare is going to peak at the vertex 314, and x represents the seconds, f of x represents the height. We want how high the flare goes. So we're going to be looking at the y-axis. And here we can see that that's going to be 14. So we're going to write 14 feet. Now let's turn our attention to how long the flare is in the air. And here, notice that the flare is in the air during this time that I'm emphasizing in yellow. Now you can see that this time is in between both of the x-intercepts, and the x-intercepts are 5.6 and 0.4. We can calculate this distance by subtracting the x-intercept on the right with the x-intercept on the left. So here we get 5.6. If we subtract 0.4, this gives us about 5.2, because recall that these were approximations to begin with. So the flare is on the air for about 5.2 seconds. So we're going to write 5.2 seconds.